All right, so welcome to our third class in Physics 101. In today's class video, I'll be taking you guys mechanics. Now let's move straight to the video, okay? Now in this class video is divided into 5 categories. In the first category, I'll talk about this aspect. In the second category, I'll talk about linear motion. In the third category, I'll talk about vertical motion, which is very important. Then fourth category, talk about quadratic formula as regards to um, motion. Then in the fifth category, that is when we start solving exercise question in your Physics 101 textbook. Okay, now let's start. Now, mechanics is divided into two parts: kinematics and dynamics. Both of them has to do with the study of motion, but kinematics has to do with the study of motion without regarding the force causing the motion. Remember, force is what causes motion, right? Yes. So kinematics is just the study of motion without regarding the force causing the motion. Whereas in dynamics is the study of motion with regards to the force that causes the motion. Okay. Yes. Now let's move to this aspect. Now, what is motion? Motion. I'm not going to spend a lot time here, okay? Because this aspect is very important. I need to spend time in this other aspect. Now, please take notes, okay? Now, what is motion? Motion just means change of body position with time, okay? Just means change of body position with time. Then there are two categories. We have linear motion, we also have vertical motion. Though there are different types of motion. Now move to position. What is position? The position of a body is just position means the location of a body with reference to a point. The location of a body in space. Let's say this body. Let's say this body A. The location of a body in space with reference to what? To a point. Okay. So that is the meaning of position. Now move to speed. What is speed? Speed is the rate of change of distance with time. Then move to average speed. Average speed means the total distance traveled divided by the time of a body. Then move to velocity. The velocity of a body is the rate of change of displacement of that body with time. Then move to this other aspect, which is very important: average velocity. Now, what is average? What is the average velocity of a body? Now, the average velocity of a body is the total distance. Total distance covered by that body divided by what? By the time. So it's S2 minus S1 divided by what? By the time. Okay. So the average velocity is just the total distance. I mean the total displacement rather, not distance. Okay. Is the total what? Is total displacement. Is total displacement traveled by that body divided by what? Divided by the time. So S2 minus the S2 minus S1 divided by total time. That will give you what? That will give you the average velocity. Then now what is uniform? Please take note, this is the formula for what? Average velocity, okay? This is the formula for average velocity, which means total displacement divided by what? The total time, okay? Yes, this is the formula for average velocity. Now, uniform velocity. What is uniform velocity? A body is said to move in a uniform velocity if that body moves in equal displacement in equal time interval. Okay, uniform velocity of a body is said to move in a uniform velocity when that body travels in equal displacement in equal time interval. Now let me explain. Let's say, for example, in the very first seconds, the body travels two displacements in that very first seconds. Now, in the other next seconds, the body will travel what? Another two displacements. I don't know if you understand. Now, let me break it down, okay? Now, remember, the uniform velocity of a body is said to be in uniform velocity when it travels equal displacement in equal time interval. It means that in every time, it will travel what? It will travel an equal displacement. Let's say in the first seconds, it travels what? Two displacements. Now, what will be in the second seconds? How many displacements will it travel? We also travel what? Two displacement. If you had everything to be what, it will be 4 displacement. I don't know if you understand. So why is this trying to tell you that uniform velocity is when a body travels what equal displacement in equal time interval. In the first seconds, it travels what 2 displacement. In the second seconds, you travel under 2 displacement, making it what 4. In the third seconds, you travel what under 2 displacement, making it what 6 displacement. I don't know if you understand. So that type of velocity is known as what uniform velocity when the body travels equal displacement in equal time interval. You will see that in every seconds the body travels two displacement. Okay, so this is an example of what uniform velocity. Now, what is acceleration? The rate of change of the rate of change of what velocity with time. Now, what about uniform acceleration? Uniform, a body is said to move in a uniform acceleration when that body travels with what? With a constant velocity. In other words, when the body travels equal velocity in equal time interval. Let's say in the very first seconds, it travels 2 velocity. In the next seconds, which is the second seconds, you travel another 2 velocity, making it what? Making it 4. And so on. Okay, so that is all about this aspect. Okay, now please take note. Remember, I told you guys that I told you guys the average velocity is what total distance divided by what by the total time, right? Yes. Now take note. When a body is moving in a uniform acceleration, when a body is traveling in a uniform acceleration, the average velocity of that body, the average velocity of that body is equals to what? The final velocity plus what? The initial velocity divided by what? 2. Okay, so um, when a body is moving with a uniform acceleration, the average velocity of that body, remember this is the formula for average velocity, which is total displacement divided by what? The total time, right? Yes. Now, when a body is moving with a uniform acceleration, the average velocity of that body is equals to what? The final velocity plus the initial velocity divided by 2. Okay, so please take note of this. Okay, now let's move to um the next aspect, linear linear motion, which is motion in a straight line. Okay, now please take note of all this. I know that you guys might be familiar with this before. When a body starts from rest, the initial velocity is usually 0, which is very important. When a body starts from rest, when a car starts from rest, when a train starts from rest, the initial velocity is usually 0. Now, when a body comes to rest, the final velocity is what? Is 0. So please take note of this aspect. Now move to this place. Now this formula, these are the 3 equations of linear motion. V equals to u plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration of the body, while x is the distance of the body or displacement. Okay, t is the time. Okay, so please take note of all this. In summary, when a body starts from rest, the initial velocity, which is u, the initial velocity of that body is 0. Okay, because initially the body is not moving. Okay, then when a body comes to rest, the final velocity is what? Is 0. Okay, yes, and please take note of this aspect. Okay, now let's move to the most interesting and confusing part of this. All right, so we continue with the third part, which is vertical motion. Now, what is vertical motion? Vertical motion is just motion that has to do with height. Okay, motion that has to do with height. Now, if you look at this part of the ball, let's focus at this very point. Okay, now these are the 3 equations of vertical motion. Okay, now it's just like linear motion, the equations of linear motion. V equals to u plus at, s equals to ut plus half at squared, something like that. Okay, but in vertical motion, a turns to g, s turns to h. Okay, so this is all about the equations of vertical motion. Now, if you look at this part of the body, you find out that g is equals positive. You see g equals negative. Now, when a body, please take note because this part is very, very important. Okay, this part of vertical motion and as well as this other parts, they are very important because we usually make use of them in projectile as well. Okay, yes. Now, when a body is when a body is moving, when you throw a body upward, when you throw a body upward, what is the symbol of what is the sign for G? And when a body is falling downward, And when a body is falling downward, what is the sign for G? Okay, is it that when a body is going up, or is it that G is positive? Or when a body is going downward, is it that G is or negative when the body is going downward? Now, this is one of the most confused part of vertical motion. The sign of G. Whether if a body is moving upward, if the sign of G is it positive or is it negative, or whether a body is moving downward, if the sign is negative or positive. Now, it all depends on what? On the coordinates you use. I don't even understand. It all depends on what? On the coordinates you use. Now, before I continue, just please take note that gravity always acts downward. Okay, gravity always acts downward. Okay, and the the sign of gravity does not depend on what the direct is not affected by the direction of motion. I don't even understand. The sign of gravity is not affected by direction of motion. It's only affected by what? By the coordinates you use. And if you get now, if you remember in our previous class in vector, when I told you guys that moving upward is positive, moving upward, remember north, which is up, is positive. South, which is downward, is negative, right? Yes. Going to this side is going to the east is positive, going to the west is negative. Now, in your textbook, you will find that you will see something like this in your textbook. When a body is going upward, if you see that they will use G as positive. And when that body is going down, they'll use what? They use G, they will use G as negative. And in another scenario, when the body is going up, they'll use G as what? Negative. And when the body is falling down, they'll use G as what? They will use G as positive. It will look as if these two are contradicting themselves. Now let me just make everything clear. It just depends. The sign of G depends on what? Depends on the coordinates you use. I don't know if you understand. Okay. It depends on the coordinate you use. Now please take notes, okay? Now, when a body it depends on what? It depends on the coordinate you use. If you are going up, it's usually positive. When you are going down, it's usually negative. In the other side, these are other coordinates. When you are going up, it's usually negative. And when you are going down, it's usually positive. Okay. Now, please, this is the part we usually use in vector. Okay, very very important. Now, like I said, it depends on what? It depends on the coordinates, okay? Now, this coordinates only works for what? Only works for vector pointing. Now, let's start with this very first equation. Now, whenever a body is going up, whenever you throw a body upward, the velocity, and like what I said, it depends on what? It depends on the coordinates you use. Are you using this coordinate, or are you using or are you using this other coordinate? Now, when the body is going upward, the velocity is usually what? If you use this first coordinate, is the velocity is usually positive, okay? When it's first coordinate, when the body is thrown upward, velocity is usually positive because why? Because going up, according to this coordinate, going up is usually what? Usually positive, okay? Initial velocity, same thing for the initial velocity. When a body is going upward is usually what? Usually positive, okay? Same thing goes for displacement of, or which we can call height, okay? When you throw a body upward, the dis and that is and under this coordinate, when you throw a body upward, the height will usually, or the displacement usually be what? Usually be positive, okay? Yes. So usually be positive. Now, if we still use this same coordinate, if that body, or if a body is falling down using this same using this first coordinate, like what I said, the sign of I'll move straight. I will go soon. I will move straight to G. But let me just deal with this part first, okay? So, like what I said, it depends on the coordinate you use. In the end of the day, you will arrive at the same answer, okay? Now, using the same coordinate, if the body is falling down, our what? Our final velocity is what? Usually be what? Usually negative. Our initial velocity will still be what? Negative. Then our height, or our displacement rather, will still be what? Will be what? Will be negative. That is when we use this first coordinate. Okay. Now, using the second coordinate, it's going to be the opposite. If a body is thrown upward, the velocity will be what? Will be negative, because why? Going upward is negative according to this coordinate. The u will be what? You will still be negative, because why? Going upward is what? Negative, right? then the displacement of the earth will still be negative because why? Because of this coordinate. Now, if that body or when a body is falling down, according to this coordinate, when a body is falling down, the final velocity will be what? Will be positive, the initial velocity will be positive, as well as what the earth will be what? Will be positive. Right. Now, let's move back to G. If a body is thrown upward, like what I said, it depends on what? It depends on which coordinate you use. Okay. Now, when a body is going upward, when a body is going upward, is G positive or what? Is G negative? Using this first coordinate. Using this first coordinate, when a body is thrown upward, is G positive or is G negative? Now, G will be what? G, please take note. G always acts, like what I said, gravity always acts downward. G always what? G always acts downward. And G, the sign of G is not affected by what? By the direction of, it's not affected by the direction of the motion. It's only affected by the what? By the coordinate you use. Okay? So if a body is thrown, if a body is thrown upward, G, using this first coordinate, will G be positive or will G be negative when the body is going upward? When the body is going upward, G will be what? G will be what? G will be negative. Because why? G always acts downward. Okay? So when a body is thrown upward using this first coordinate, which is the normal one we usually use in vector, this is the normal one we usually use. When a body is thrown upward, normally according to the rest of them, and according to the rest of them, these other quantities, they are not they are usually affected by the direction of motion of the object. Unlike G is not affected. If you are going up, G will still act downwards. If you are going down, if the body is falling down, G will also what? Act downward. Okay. So for a body going up, using this coordinate, G will be what? G will be negative, okay? Yes. So when a body is going up, when you throw a body upward, using this, please take note, this is very, very important. Like very, very. When you throw a body upward, using this first coordinate, G will be what? G will be negative because where? G always acts downwards. Okay, yes, G always acts downward. And remember, going downward in the first coordinate, downward is what? Usually negative. Okay, so this is where G is usually negative in this first coordinate. Okay, because using this first coordinate, upward is positive, downward is negative. So regardless of the motion of the body, if you throw a body upward, G would what? G using this first coordinate, G would be what? Negative because where? G always acts. Gravity always acts downward. Okay, it does not depend on the direction of the motion. If the same body is thrown, if the body is falling downward, our G will still be what? G will still be negative because where? G acts downward using this first coordinate. Okay, yes. Now, what about using the second coordinate? If you throw, remember, like what I said, G is not affected by the direction of motion of the object because where? G always acts downward. Okay, G does not act upward; it always acts downward. Okay, so using the second coordinate, when a body is thrown upward, what will be the sign of G? Will G be negative or G be positive? G will be positive because G always what? Always acts downward. Okay, yes. So when the body is thrown upward, G the gravitational force or G acting on that body will always be positive because using this, that is, it depends on the coordinate you use. Okay, it depends on the coordinate. Using the second coordinate, when a body is thrown upward or when a body is thrown downward, G will be what? G will always be positive because why? According to the second coordinate, but because why? G always has downward, and apart from that one, downward in this second coordinate is usually what's positive. Okay, yes. But in the first coordinate, G is usually negative. Yes, usually negative because in this second coordinate, downward is usually negative. Yes. Even though you throw that body up, even though the body moves upward, and we know that upward is positive, even though according to this, using this first coordinate, even though the body is thrown upward, and we know that upward is positive, based on the fact that G always acts downward, G will be what? The G acting on the object is what? Negative. For example, let's use this first coordinate. I will solve questions and we use both of the coordinate to solve and we also arrive at the same answer. Okay, yes. So please just take note that the direction of G depends on what? depends on the type of coordinate used, and it doesn't depend on what, and it doesn't depend on the direction of motion. But remember, now remember, neglecting G and the, let's focus on this other part. When you throw a body upward using the first coordinate tell you that north is positive and downward is negative. Second coordinate tell you that upward or not is negative, downward is what is positive. Okay, now that's what using this quantity, velocity, initial velocity, and displacement. Remember, we can time is not affected by any coordinates because why, time is a scalar quantity. This coordinates only works for what, y-axis, x-axis only works for what, only works for vector. Okay, because vectors they have direction, whereas time is a scalar quantity and time does not have direction. So we can never see negatives. We can never see negative time. Okay, so not so we neglect uh, t. Okay, so now uh, displacement or height. Okay, so when a body using these first coordinates, when you throw a body, when the body is going upward, the velocity is usually what, usually positive because going up is usually positive. Okay, initial velocity is still positive. Okay, because we are going up. Then the displacement or the height is will still be what, is still positive because why, the body is going upward using this first coordinate. Like what I've said, and I'll repeat it again. Um, the sign of this quantity depends on what? It depends on the direction of motion of the object, unlike G. Okay, so moving up using this first coordinate, moving upward, all these coordinates that will be positive. Now, but when you are moving downward using this first coordinate, you realize the quantity will be negative. But using the second coordinate, moving when a body is thrown upward, and when body throw upward, remember going upward is value negative. So all these points will be all negative. Yes, so negative. But when our body is falling down, and remember going downward in second coordinates is usually positive. Okay, so that's why all of them are what, positive. You will see the application soon. But when it comes to G is not affected by what, direction of what, the motion of the object. Okay, yeah, D or the sign of G depends on what, the type of coordinate you use. If you throw a body upward, or your body is falling down, we all know that G will always act downwards. Okay, G always acts downwards. Gravity always acts what, downwards. Okay, so in the first coordinate, when we go downwards, usually negative. So this is where G is usually negative in the first coordinate because G acts downwards, and in the downward direction is usually what, is usually negative. Now, in the second coordinate, like what I said, G is not affected by direction of motion. If the body is moving upward or the body is moving downward, G, G will be in the second coordinate. G is positive because where, moving downward in the second coordinate is usually positive, and G always what, acts downward. So this is why in the second coordinate G is usually positive. So if for example, okay, let me give you guys for example. For example, let's say a ball is thrown upward. The G acting on the body is it usually negative or is it usually what? Is usually positive? Is it usually negative or is it usually positive? It depends on what? It depends on the coordinate you are using. Okay. In the first coordinate, we all know that G always acts downward, right? G always acts downward. So if we use the first coordinate, G will be what? Negative. Okay. So even though the body is even though the ball is thrown upward, even though the ball is thrown upward, and we know that upward is usually positive, the G will be negative because it acts downward. So same goes for here, okay, which is the opposite. So please take note of this, okay. So you cannot just say when you throw a body up, you cannot just say G is negative, and when you throw a body downward, when the body is falling down, G is positive. No, it depends because most textbooks usually those scenarios, okay. So it depends on what? It depends on the type of coordinates you are using, okay. Yes. Now we move to quadratic formula because you just need to know this because we usually use this to solve in a particular question. Now let's solve one particular question using under vertical motion, where you will see the application of all these things I'm talking about. Okay. Okay, so now if you look at this question and the question one in your physics 101 textbook, they said a photographer in a helicopter ascending vertically at constant rate of 12 meter per second. What are I telling you? They're telling us that a photographer in a helicopter ascending, what ascending? Let's say this is a helicopter and the helicopter is moving up, or ascending means moving up. Okay, so the helicopter is moving upward with a at constant rate of what 12.5 meter per second. So the velocity, which is the initial velocity, this said the helicopter is moving with a velocity of what of 12.5 meter per second. Okay, yes, 12.5 meter per second upward. That is this is let's say this is the helicopter. The helicopter is moving with a velocity of what 12.5 meter per second upward, right? Yes. Now, these are the two coordinates, like what I told you guys earlier. Move in the very first coordinate, when you are going up is usually positive, downward is usually negative. While in the second coordinate, when you are going upward is usually negative, while downward is usually positive. Now, in this question, we use the very first coordinate to solve, and I will get my answer. Then we also use the second coordinate to still solve, and we will also arrive at the same answer. Okay, so now let me use this very first coordinate. Okay, now the helicopter is moving what? Is moving upward with a velocity of what? The velocity of 12.5 meter per second. Now, since we are using the first coordinate, moving upward is usually what? For velocity and the rest of them is aside g. Moving upward is usually what? Usually positive. Okay, so the velocity is usually what? Usually positive. Okay, so the initial velocity of the helicopter is what? 12.5. Okay, that is positive 12.5. Okay, now let's continue. A photographer in a helicopter ascending vertically at constant rate of 12.5 meter per second accidentally drops a camera. Okay, so I'm coming. Let's say okay, u is 12.5. Okay, now the photographer inside the helicopter drops what? Drops a camera. Drops what? A camera downward. Okay. Yes. Now accidentally drops a camera. When you drop something, does the thing go up, or does the thing go down? The thing usually goes down, right? So it drops the camera. The camera is falling down. Accidentally drops a camera as the window when the helicopter is what? Is 60 meter. When the helicopter is what? Is 60 meter above the ground. Okay, let's say this is the helicopter here and this is the ground. Okay, so the helicopter is what? Is 60 meter. The helicopter is only 60 meter above the ground. How long will it take the camera to reach the ground? They are looking for what? The time at which we're looking for the time at which the time it takes the camera to reach the ground. Okay, now the initial velocity is usually what? This velocity is the initial velocity of what? Of the helicopter. Okay, and the helicopter is usually what? Usually at 60 meter above the ground. Now, is h positive or is h negative? Remember, this helicopter is ascending, right? Yes. Now, but if you look at it, they say accidentally drops a camera as the window when the helicopter is 60 meter above the ground. The helicopter is 60 meter above the ground. Now, when the camera, let's just say that the camera falls from what height? From 60, right? It comes from 60 downwards, okay? Fall from the camera is falling from a height of what? Of 60 meter downwards. So, is the height or is the displacement positive or is this displacement negative? Since we are using the first coordinate and since we are using the first coordinate and the camera is falling downward from a height of what? 16 meter. And remember, going downward according to the first coordinate is usually what? Usually negative. So the height will be what? Will be negative. Okay, the height will be negative. So h or displacement will be because of what? Minus 60 meter. Okay, so the height at which are they being that the camera was thrown upward from this height, or you say for example, or let's say for example a body is from the ground is thrown upward to a height of 60. Remember, going upward using the first coordinate, the height would have been what? Would have been positive. The reason why the height is negative is because the camera is falling downward from that height. Since you are falling down from that height downwards, and remember we are using the very first coordinate to solve. So you are going downward. Downward is usually negative. So this is where the height is usually what? Minus 60. Okay, so what about G? Yes, remember G is equal to 9.8. Now, is G positive or is G negative? Since we are using the very first coordinate, and remember, even though I didn't mean that this camera is going upward, eh? G will always add downwards, right? Yes, G will always go down. We always add downward. So using this first coordinate, since G always adds downwards, going downward is usually negative, right? So G is still what? G is what? Is negative 9.8. I don't know if you understand. And even we are using the second coordinate, and we all know that G adds downward. According to the second coordinate, going downward is positive. So G would have been what? Would have been positive. Okay, that is if we use the second coordinate. Okay, but since we are using the first coordinate to solve, G is usually what? Minus 9.8, because why? G always adds downward. It does not depend on the direction of the camera. Like what I told you guys earlier, it does not depend on the direction of motion of the object. Okay, even though the camera is going upward, and we all know that G always adds downward, right? And according to the first coordinate, when we are going downward, it's the sign is usually negative. Yes, G always adds downward. G does not add upward. Okay, so G is equal to what? Minus 9.8. Now they are telling us to look for what? To look for the time. How long will it take the camera to reach the ground? Okay, using this theory, looking at this theory equation of vertical motion. Since we have height, we have u, we have g. Now they tell us to look for what? They are telling us to look for what? They are telling us to look for time. So we are going to use what? This second equation. Okay, I'm going to use the second equation. Okay. All right. So I'm going to use the second equation. So our height, using the second equation, our height or our displacement, rather, remember, displacement is a vector quantity. So our displacement is what? Usually minus what? Minus 60. Okay, equals to u is what? Is positive 12.5. Okay, then times what? Time, which we are looking for. Then plus. Okay, now remember, plus or minus. Now in vertical equation, the equation is either positive or negative, depending on what. What makes the equation either positive or negative? Usually G. Remember, G can either be negative or can either be positive, depending on what? Depending on what? The coordinate, and not the direction of the motion. Okay, so it depends on the coordinate we are using. Okay, now according to the coordinate we are using, since G usually goes downward, G usually acts downward. According to the first coordinate we are using, will G be positive or will G be negative? G will be what? G will be what? Negative. So we are going to use negative here. Okay, so to be what? Negative. Okay, minus half times G. G is what? 9.8. Abi 9.8. Remember, this is minus 9.8. So this minus is the minus here, right? Okay, so minus half times 9.8, then times what? Times t square. So times t square. Okay, half times 9.8 will give us what? Half times 9.8 will give us 4.9. So everything we have here will now be what? 4.9 t square. Okay, so we are looking for what? We are looking for the time. Now, are we going to, based on the fact that this t takes square and this other does not take square, we cannot easily subtract it. I not subtract them because one of the time is one of them is taking square. The other one is what? Is not taking square, so we cannot easily subtract them. Now, if you look at this equation that we arrived to, it looks similar with this other equation. I don't know if you understand. It looks similar with what? With quadratic equation. Now let's go back to this aspect. Now this is the formula. This is the quadratic formula. This is the correct formula. This other formula here, this one is derived from this. This one is gotten from this. Okay. So this is the quadratic formula. Okay. So if you look at this equation looks exactly like this. I don't know if you understand. If you look at it, t square s square t x. I don't know if you understand. Okay, so since this equation is a quadratic equation, we are going to use what? This formula to solve. I don't even understand. We are going to use this formula to solve for time. Okay, we are going to use quadratic formula to solve. So we'll get to answer. Okay, so now which of them is A and which of them is B and which of them is C? Now this 4.9 minus 4.9 is what? Is A. Okay, now minus 4.9 is A. Why is minus 4.9 A? Because what? Because 4.9 takes what? A variable that has square. which is t square. And remember, a or the variable that a carry, does it have square or not? The variable has square. So this is where 4 minus 4.9 is what? Usually a, because it takes a variable which is t square. Now, which of them will be b? To be 12.5t, because when if you look at b only takes one single variable and it's not square. And if you look at this, 12.9 usually takes what? A single variable which is t. So b is 12.5. Then what about c? Does c take any variable? No, c does not take any variable. So that is how we know that variable can be variable just can are just letters. Okay, so that is how we know that c is what is. So c is minus 60. Okay, now if you look at this, a square, as square plus bs plus c. Now, it does not, please take note, it does not mean that the very first value does not mean that the very first value is the a. Please take note. It does not mean that the very first value is the a. Please just also know, we are just know quadratic formula, because you still use it to solve in projectile. Okay, so it does not mean that the very first value it does not mean that the very first value will always be a, because a is one that usually start the equation. Okay, so it does not mean like that. Now, how do you know a will always take a variable. We always carry a variable that has square, while b will only takes a single variable, while c does not take a single variable. And it does not mean that the last value is c. No, it does not mean like that. Okay, so let's solve using this equation, using almighty formula, the one we usually call almighty formula. Okay, so in the place of x, since we are looking for time, in place of x, we'll put t, okay, which is equals to minus. Now our b is what? Is 12.5, right? So b will be what? 12.5. Then plus minus root b again is what? B is 12.5, so 12.5 all square. Then minus 4 times a. A is what? A is minus 4.9. So now be what? Now be bracket open, minus 4.9, bracket close. Then times what? C. C is what? Minus 60. So now you want minus 60 all over what? 2a. Our a is what? It could now be 2 times what? Our a is what? Minus 4.9. Okay, so let's continue. Okay, so let's continue. Now be what? T is equals to minus 12.5 plus minus root. Now, why is it square? The square of 12.5. The square of 12.5 is square of 12.5 is 156.25. So the square of 12.5 here is what? Is 156.25. Okay. Now, minus 4 times minus 4.9 times minus 60. Minus 4 times minus 4.9, then times minus 60. We give us what? We give us minus 1000 minus 1176. Okay, all over 2 times minus 4.9 will give us what? Minus 9.8. So if we subtract these two places, we subtract them, we have what? We have minus. If we subtract these two places, I'm coming. T is equals to what? Minus 12.5 plus minus. If we subtract these two places, we arrive with what? Minus 1019.75, all divided by what? 9.8. Okay, so let's continue over this side. Okay, let's continue over this side. We are looking for what? We are looking for time. Okay, so since why are we using quadratic formula? Because the equation lands as a quadratic equation, so that is why we are using quadratic formula. Okay, so let's continue. Now, if you see this plus or minus, according to a quadratic equation, our answer will always be 2. Okay, we always arrive at 2 answer. Now, this plus or minus, it means that this whole equation is really 2. One that has plus and then the other one that has minus. Okay, this plus and minus means that the equation is really 2. One takes plus, the other one takes minus. Now, let me break the equation into 2. So it will be t equals to minus 12.5, then plus root minus 101 9.75 divided by what? Minus 9.8. Or t is equal to minus 12.5, then minus root minus 1019.75, all divided by what? Minus 9.9. I mean minus 9.8. So the equation is valid 2. The one that has plus and the other one that has what? The other one that has minus. Okay. So let's solve for this one, then we'll solve for this other one. Let's start with this one first. The square root of minus 1019.75. Okay, the square root of 1019.75 to give us 31.933. So now equals to minus 12.5 minus times plus will give us minus. Okay, then 31.93. Okay, so the square root of this one is 31.93 all over what? Minus 9.8. Okay, so when we subtract these two parts, let's subtract it. Minus 12.5, then minus 31.93 to give us minus 44.43 divided by what? Minus 9.8. So if we divide it, we arrive with what? 4.5. So this minus, you cancel this minus, we arrive with what? We arrive with 4.5, which is approximately what? 5 seconds. Okay, so the very first time is what? Our very first time is 5. Okay, now what about this other one? If we take the square root of this part, we arrive with what? We arrive with 30. We arrive with I'm coming minus, we arrive with 31.93, right? Yes, so this is minus, these are under minus. So let's add everything. Minus 12.5 minus 31.93 to give us 19.43, then divided by minus 9.8. So if we divide this, we arrive with what? 1. T is equals to minus 1.9, which is approximately what? Minus 2 seconds. So our answer is either 5 or is either minus 2 seconds. So which one are we going to choose? Because it will be only one option in a particular question. Now the right answer will be what? Is 5. T is equals to 5. The reason is because time does not take a negative value. So the right answer is what? Is 5. Because this negative value means that we are going back in time. I don't understand. It means that we are going back in time. And going back in time is impossible. So the right answer is what? Is t equals to 5. So what have we done so far? The question that they gave us to calculate for the time it takes the camera to fall to the ground. The time it takes the camera to fall to the ground is what? Is 5. Now the B part. Okay, the B part, what will its speed be when it hits the ground? So they are telling us to calculate, since we have got the time, they're telling us to calculate for what? Calculate for the velocity with which the using this first equation of vertical motion, v equals to u then plus minus gt. Now they're telling us to calculate for the velocity with which the with which the camera falls to the ground. Now, okay, let's continue. Remember, our u is what? Our u is, oh, what is the u? Okay, it's 12.5. Yes, 12.5. Now the u, which u is what? Usually is positive 12.5. Remember, this 12.5, which is the velocity, was the velocity with which the helicopter was ascending. Remember, was the velocity with which the helicopter was ascending. Since we are using the first coordinate, yeah, going upward is usually what? Usually positive, right? So since we are using the first coordinate, the helicopter was ascending with a velocity of 12.5. Since it's going up, the velocity is positive. So u is what? 12.5. Now, are we going to, is it plus or minus are we going to use? Are we going to use minus? Is our g positive or is our g negative? Now, since we are using the first coordinate, and since gravity always adds downward, even though the camera was going upward already, g will always go downward, and even though the camera is going downward, G will also go downward. And going downward in the first coordinate is usually what? Usually negative. So our G is usually what? Usually negative. So that means minus what? 9.8. Then times what is our time? Our time is 5. If we do everything, 12.5 minus 9.8 times 5, we arrive with what? We arrive with minus 36. We arrive with minus 36.5. So our final velocity, the velocity with which the camera hits the ground is minus 36.5. Now, this minus tells you what? It tells you that since we are using the first coordinate, minus, what does minus tell you? It tells you that the body is going downward, right? So that is telling you that it's very correct because the camera was falling down. Yes. So the velocity with which it was falling down is what? Is minus 36.5. That minus tells you that, oh, the velocity, the body is moving downward. And remember, when we're moving downward in the first coordinate, usually we're negative. So this is the answer. Now, let me use the second coordinate. If we arrive at this answer 36.5, are we going to arrive at this answer? Let me tell you, even though we use the second coordinate, we also arrive at the same answer. Okay, so I want to just use the second to save time. I want to just use the second coordinate for just this aspect. Okay, let me use it for just this aspect. I'm not going to use it for this quadratic question because to solve is very it take a long time. Okay, so now let me just use it for this for this question, the B part. Okay, so now second coordinate. Second coordinate is when we are going up is negative, going downward is positive. Okay, yes. Now remember, V equals to what? U plus minus GT, right? Yes. And our time is what? We have gotten our time to be 5, Abi. Yes. Okay, so U is 12.5, Abi. Yes, that is the velocity of the helicopter. Now, since we are using the second coordinate, the helicopter was what? Was ascending. Yes, with a velocity of what? 12.5. Since it's ascending, that is going upward. In the second coordinate, since we are using the second coordinate, going upward is what? Will be negative, right? So remember, the helicopter was ascending with what? With a velocity of 12.5. Since we are using second coordinates, going up will be what? Will always be negative. So the helicopter velocity is minus 12.5. But remember, when we are using the very first coordinate, the helicopter velocity was positive, right? 12.5, right? Yes. But since we are using the second coordinate, the helicopter is moving upward to what? 12 minus 12.5. Now, what about G? Okay, so here will be what U equals to minus what? 12.5, right? Now, what about G? Are we going to use plus? Are we going to use minus? Since we are using the second coordinate, and since we all know that G always starts downward, G does not add downward. And even though the camera is going downward now, or is going up, or anyone, even though the camera is going downward, G will also still add downward. Or even though it's going upward, G will still add downward. So our G, since G always starts downward, in the second coordinate, G will be what? G will be positive. So here will be what? Positive 9.8. Then times what? T is what? 5. So if we do everything here, let's see what is our answer. Okay, so minus 12.5, then plus 9.8 times 5. If we do everything, we arrive with what? We arrive with V equals to what? Positive 36.5 plus 36.5. So what does it tell you? Remember, in the very first, when we use the first coordinate, we got what? Minus 36.5. This minus told us that it was going down. Now, according to the second coordinate, going down is it positive or is it negative? It is positive, right? And when we solve, we get our answer to what? Positive 36.5. Abi. So let's tell you that, oh, this velocity is what? The body is falling down. And remember, going down is usually what? Usually positive, according to what? To the second coordinate. Okay. Now, this is where the confusion occur. Now, okay, let's say for example, now they ask you this question in exam and they place minus 36.5 and plus 36.5. What will be your answer? Even though we both know that, oh, this one is correct, this one is also correct. That is as regards the second coordinate. So what are you going to do? And in your textbook, this is one that in your textbook, which is minus 36.5. Minus tells that you're going down. Now, but what here plus 36.5? It tells that it's going down. That is according to the second coordinate. So my advice for you guys is that I will always advise you that anybody to use what? To use the first coordinate, the normal one we use, the normal one we know. Okay, yes, the normal one we know. But the normal one we know, which is what? Going up is positive, going down one is what? Negative. We all know that north is positive. We all know that south is negative. According in vector, I told you guys that one. Okay, east is positive, west is negative. Okay, so I will always advise you guys to what? To use the very first coordinate. Okay, use the very first coordinate. Okay, yes, but just to have knowledge of the second coordinate. Okay, and at times, most times, textbook contradict themselves. Yes, textbook contradict themselves. You will see it in a textbook. They will say when you throw a body upward, G is negative. Then you will still see it again when the body is going upward, G is positive. They will use positive G. So the textbook at times contradict themselves. Okay, so please use the very first coordinate. Okay, going up is positive, going down is negative. Okay, yes. And remember, when you are going, remember, G always has that one. So when you are going down, using the first coordinate, G is negative. Okay, using the second coordinate, when you are going down, G will be positive. Okay, so this is all about vertical motion and also please take note of the quadratic equation. Yeah, just know which one is A, which one is B, which one is C, because we make use of them to solve in project time. Now let's move to the second question in mechanism. Okay, let's solve the next question.